Good day, everyone. On behalf of my research partners, I am pleased to present our research study entitled Clustering and Classification Models for Students' Grade Detection in E-Learning. For the introduction, the significance of intellectual capacity is well documented in academic and professional domains, but we understood very little about other equally critical characteristics that foresee success. Studies have proven learners' cognitive ability is insufficient, so they must surmount hurdles, be dedicated and disciplined, and maintain high motivation to achieve goals while remaining resilient. Duckworth presented grit as an intangible individual quality of perseverance, willingness, and determination to accomplish long-term aspiration despite setbacks. Studies have shown that gritted people continually push to give their best without regard for constraints. And likewise, it is essential to understand that grit is not innate but dynamic, can be identified and cultivated. However, one needs to adopt a growth mindset to build grit by recognizing that intelligence and talent can be fostered through hard work and the willingness to explore new approaches as an opportunity to learn and progress. Literature reveals that high grit levels consistently predicted individual success than intelligence alone. Studies have also revealed that grit predicted graduation rates, higher GPAs, retention rates in military cadets, and long-term employments among the few. For quantifying the characteristic, a 12-item grit scale, which is a questionnaire designed by Duckworth, assesses the attribute with a scoring system. However, published articles laid out the problems with questionnaires, such as prone to inaccuracies due to the frame of reference bias and social desirability. While considerable efforts employed grade as a tenet of success, no existing studies glance into the prospect of identification of the trait through learners' behavior in e-learning using computational methods. Grid analysis in a learning environment is still in its inception. We conducted an experiment to investigate possibility of detecting grid in remote learning. This study's relevance cannot be overstated as e-learning, pandemic or not, has become increasingly prevalent in higher education institutions worldwide. Our research contribution is a generative machine learning model for identifying grid in e-learning to advance the discourse. This initiative will aid educators at all levels by utilizing innovative data analytics to ascertain student characteristics and deliver interventions to help learners build non-cognitive skills. For the methodology, for the first part, the research was inspired by a model course in Programming 1, which is an online complementary learning resource to traditional face-to-face classes for sophomore tertiary students. It has 562,174 recorded interaction logs spanning 4 years starting from 2014 to 2017. We purposefully selected 500 most active accounts based on equal standard distribution. And aside from the e-learning log data, we also collected their grade scale questionnaire results, final course grades, and current job levels for correlational purposes. So for the grid-related learning attributes in e-learning, we have formulated 5 grid-related learning attributes. So we based these attributes on literature. And the first one is a self-motivation, which was determined by the number of instances a learning attempted to reach a passing score on self-assessment exam. The next one is self-discipline, which was identified by the number of hours spent in the course outside the authorized class schedule. The third attribute is diligence, which was determined by the number of on-time submissions of mandatory tasks. The fourth attribute is perseverance, which was determined by the number of attempts to finish and provide correct solutions to complex programming simulations. And the last attribute is sustained interest, which is a measurement of consistency of logins to the course. So for the feature mapping for clustering, so as you can see in table 1, so it depicts the mapping of students' extracted data from the LMS database according to the characterization of grid detailed in the previous discussion. So this is based on the student's behavior in e-learning. And for the access consistency calculation, which is the sustained interest, we use dynamic time warping to quantify the attribute by comparing two temporal sequences, which is designed to generate the input time series to determine resemblance or disparities. So typically, the resemblance or disparities is determined by transforming the data into vectors and computing the Euclidean distance between vector space points as described in this equation. So if two sequences are equal, their distance is 0, while a distance value of less than 1.20 indicates dissimilarity based on the simulated t-test value. We also set a consistency baseline based on the average login hours of all learners for 18 weeks, which is equivalent to 1 semester. And an algorithm is designed to prevent penalizing students for exceeding the maximum weekly threshold. So for the grid level detection through clustering, we use density-based spatial clustering, which is efficient in handling noises and catches outliers. The data are also normalized by min-max scaling. So we also derived 5 highly separable clusters for grid level identification based on silhouette scores. So these are the values in the respective clusters for cluster 1 to cluster 5, which you can also see in this figure. Final grid levels are identified through majority of votes, which is similar to ensemble modeling's hard voting mechanisms for each 5 clusters. So this adds robustness to estimation. So for the grid level prediction through classification, so we partition the data set into 70-30, so 70 for the training and 30 for the testing set. Next, we implemented a tenfold cross-validation to evaluate the accuracies of various supervised learning models, including the following: the J48 decision tree, logistic regression, artificial neural network, k-nearest neighbors, random forests, support vector machines, and naive Bayes. And then for the dimensionality reduction, we utilize principal component analysis, an unsupervised feature selection technique. And as you can see in this figure, it represents that two components with 90.76% variation. And we also excluded the feature and made sure to balance the distribution for each class by undersampling with 232 each. So for that, we excluded the diligence since among the variables, it was the variable which was shown or calculated to rank the list. That's why we removed this variable. And for the model evaluations and interpretation, so we estimated machine learning algorithms, predictive quality, and reliability using established metrics such as F1 score, precision, sensitivity, accuracy, confusion matrix, receiver operating characteristics, and area under curve. So for the interpretations, we used permutation, feature importance, a priori algorithm, and correlational analysis, particularly Spearman rank. So for the results of the study, so in contrast to the learned parameters of a model, hyperparameters are user specified. So while providing suitable values improves the performance of machine learning, it is one of the most time-consuming and underutilized tasks in knowledge discovery. Although it is a computationally intensive technique, the benefit outweighs the drawbacks. So for the evaluation scores, Table 5 demonstrates that the random forest's robustness with an accuracy of 92.09% because it uses multiple ensemble trees capable of solving over 50. while logistic regression underperforms with 81.16%. For the confusion matrix, receiver operating characteristics and area under curve, based on the results, it signifies that the prediction of gritty individuals, which is 93.75%, is more accurate than non-gritty ones, which is 88.70%. Furthermore, figure number 4 illustrates an area under the curve rating of 0.979, which means non-random substantial predictions. And for the model interpretation via feature importance, black boxes models such as random forests are complicated to decipher because the insight is buried within its probabilistic structure, making it impossible to draw out the relationships. So our solution is to use permutation feature importance. And the results identify that perseverance with a value of 0.2587 was the best predictor, followed by sustained interest, followed by self-motivation and self-discipline. Okay, so for the model interpretation by association rule mining, so for discovering interesting relationship and frequently association causality, data reveal that grit levels are positively linked to perseverance. And then students with low grit shows combinations of low self-motivation and sustained interests, low perseverance, and low self-motivation. So for the consistency of clustering and classification, we observe the higher score for the high grit class with 97.63%, while 97.61% for the low grit groups. Both our algorithms categorization are not far off, and the calculated consistencies are highly acceptable. And for the consistency of grit scale questionnaire versus machine prediction, so we found higher consistency scores for random forests with 94.07% and 93.49%. So density-based spatial clustering yields 91.85% and 90.55%, and all are acceptable consistency ratings. So for the correlation of grit attributes to course rating, so we opted to utilize a Spearman-Frank correlation instead of a Pearson-R's due to the non-parametric characteristics of our data. And based on table 11, there is a generally weak correlation between the course rating with self-motivation and self-discipline. However, perseverance and sustained interest are not significant at 0.05 levels. In stark contrast, professional achievement dictates a very strong correlation with perseverance and sustained interest. Self-motivation and self-discipline are not significant at 0.05 levels. Tracer study reported that 273 of 500 graduate with high-level combinations of perseverance and sustained interest based on their e-learning behavior have a high-paying profession above the country's average wages. So for the discussions of the study, this research determines the capability of machine learning to identify fit in an e-learning environment using multiple modeling techniques. The results clearly illustrated that with the intuitive data mining strategies such as dynamic time warping, clustering, feature scaling, dimensionality reduction, hyperparameter optimization, and classification improves prediction accuracy. The study also noted that it is best complement rather than compare the strengths of unsupervised and supervised learning. Analytics ranked perseverance and sustained interest as the two most salient components of grit in agreement with various studies. Generalization capabilities of our model yields an acceptable consistency score of 92.67% against manual questionnaire method. This work disclosed a weak correlation between course rating and grit attributes, confirming several articles, whereas professional achievement shows strong positive correlations. While grit is strongly related with long-term goals, results reveal that it might not be the case for short-term academic achievements such as course grades. The lack of correlation between two variables is attributed to age-related changes in an individual's grit level similar to the findings of Duckworth. It suggests that grit may lack discriminant validity in younger people because they are still on the process of discovering their interests and continually change. Thus, this research attested that developmental changes in maturational variables could be considered significant in explaining why grit attributes are linked with long-term than short-term goals. Our studies limited only to discernible variables observed in the confines of e-learning and did not include other essential characteristics such as demographics. So for the conclusions, not all accomplishments are purely the consequence of intellectual aptitude and talent. Intangibles such as perseverance and resilience are critical factors deciding one's success. Learning and behavioral processes can now be studied in detail using students' digital traces, which previously were too expensive to obtain via conventional sources. We discovered the potential of determining learner speed through multiple stages of machine learning approaches and extensive modeling. More importantly, we shed light on the relationship of grit with academic and professional achievements. This empirical evidence demonstrates the critical nature of cultivating non-cognitive abilities, such as grit among students, which has the predictive validity for long-term achievements. Our investigation has profound implications for various educational institutions that holistic development of students' skills must be given full attention. So that will be all. Thank you very much for listening.